Here this is the problem. If the line segment connecting the point of intersections of the tangent to the ellipse at a cos theta b sin theta with its auxiliary circle, the auxiliary circle of the ellipse subtend an angle 90 degree at the center of the ellipse, that is center of the auxiliary circle. Then we have to prove that 1 over square equal to 1 plus sin square theta. The problem is if the line segment connecting the point of intersection of the tangent to the ellipse x square over a square y square over b square equal to 1 at a cos theta b sin theta with its auxiliary circle of the ellipse subtend an angle 90 degree at the center of the ellipse, that is center of the auxiliary circle. Then we have to prove that 1 over square equal to 1 plus sin square theta. Also E is the eccentricity of the ellipse. Now let us begin. Here equation of ellipse is given as x square over a square y square over b square equal to 1, and we can derive the equation of tangent at a cos theta b sin theta tangent to the ellipse. So, equation of the tangent to the ellipse at a cos theta b sin theta is the general equation of the tangent to any conic at any point is y minus y1, that is y1 is here b sin theta, x1 y1 is the point of contact, here point of contact is a cos theta b sin theta. So, y minus y1 is y minus b sin theta equal to dy dx at a cos theta b sin theta into x minus x1, that is x minus a cos theta. We can also calculate the value of dy dx at a cos theta b sin theta for this curve. We differentiate this curve with respect to x, equation of the curve with respect to x, differentiating x square, differentiating with respect to x, also with respect to x, we get 2x over a square 2y over b square equal to 1. So, into dy dx, also into dy dx equal to 1. So, dy dx equal to minus b square x over a square y. Also dy dx at a cos theta b sin theta, this is this value at a cos theta b sin theta equal to minus b square a cos theta over a square b sin theta equal to minus b cos theta over a sin theta. This is the value of dy dx, that is gradient of the tangent. So, equation of tangent is y minus b sin theta equal to minus b cos theta a sin theta into x minus a cos theta. So, a y sin theta minus a b sin square theta equal to minus b x cos theta plus a b cos square theta. So, b x cos theta plus a y sin theta equal to a b cos square theta plus a b sin square theta. If we simplify this, we get equal to a b, that is a b into 1, because a b cos square theta plus a b sin square theta equal to a b into sin square theta plus cos square theta. Value of sin square theta plus cos square theta equal to is 1. So, this right hand side is a b. So, this is the equation of tangent. This is the equation of tangent. This is the tangent. This is the tangent. This is the tangent. This is the equation of tangent. So, we can derive the point of intersection with the ellipse with its auxiliary circle. The equation of, at first we derive the equation of auxiliary circle of the ellipse. We know, we have already known the equation of auxiliary circle. Equation of the auxiliary circle of the ellipse equal to 1. Here x is major axis, that is a greater than, also here a greater than b imply a greater than b, provided a greater than b. So, this is the major axis. If we consider major axis as x and minor axis as y. So, equation of auxiliary circle is also x square plus y square equal to a square. This is the equation of auxiliary circle. The equation of tangent is bx cos theta plus ay sin theta equal to ab, and equation of auxiliary circle, which is x square plus y square equal to a square. This is the equation of tangent to the ellipse, x square over a square, y square over b square equal to 1, and this is the auxiliary circle of the same ellipse. Now, the point of intersection, we have to find out the point of intersection of these two equation, that is one is tangent and other is auxiliary circle. Point of intersection of the tangent with the auxiliary circle. Suppose x y be the general coordinates of the point of intersection of the tangent with the auxiliary circle, x square plus y square equal to a square. Now, so x y is the general point of intersection. So, we can replace y from this equation. We get ab minus bx sin cos theta over a sin theta whole square equal to a square, where x y be the general coordinates of the point of intersection. Point of intersection of bx cos theta plus ay sin theta equal to AB with x square plus y square, that is auxiliary circle, x square plus y square equal to a square. Now, from this we can write x square a square sin square theta plus a square b square plus b square x square cos square theta minus 2 ab square x cos theta. AB square x cos theta equal to a square a4 sin square theta. This is so a square sin square theta into x square plus also x square into a square sin square theta plus b square cos square theta minus 2ab square cos theta x minus plus a square b square minus a4 sin square theta, a square b square minus a4 sin square theta. This is the equation. This is also a quadratic equation in x. So, it has two roots. Suppose these roots are x1 and x2 be the roots of this equation, roots of this equation. So, from the relation between the roots and the coefficient of this equation, we can write the product of the root x1 x2 equal to a square b square minus a4 sin square theta over a square sin square theta plus b square cos square theta. Similarly, if we replace x from this equation using this equation, if we replace x using this equation, we also get y square plus replace x from using this equation, we can write x, value of x is ab minus ay sin theta over b cos theta square equal to a square. So, we can simplify this b square cos square theta y square plus a square b square minus 2 a square b y sin theta plus a square y square sin square theta equal to a square b square cos square theta. This is so b square cos square theta into y square minus 2 square b y sin theta also you can write b square y square into b square cos square theta plus a square sin square theta minus 2 square b y sin theta equal to a square b square cos square theta minus a square b square. Also you can write y square b square cos square theta plus a square sin square theta minus 2 square b y sin theta plus a square b square minus a square b square cos square theta. This is equal to 0. So this is a quadratic equation in y. So y has two values. Suppose two roots of y are y1, y2. y1 and y2 are the roots of this equation. So relation among coefficient and the roots, from the relation among coefficient and the roots we can write y1 y2 equal to a square b square minus a square b square cos square theta over b square a square sin square theta plus b square cos square theta. This is so we have got x1 so we have got x1 x2 equal to this minus a4 sin square theta over a square sin square theta plus b square cos square theta, and also we have got y1 y2 equal to a square b square minus a square b square cos square theta over a square sin square theta b square cos square theta. Now the point of intersection, so the points of the intersection point of intersection between x cos theta over a plus y sin theta over b equal to 1 and x square plus y square equal to a square. and this are x1, x2, x1, y1 and x2, y2. Now, and the line segment joining these 2 points with the center of the ellipse, with the center of the ellipse, center also the coordinate of center is 0 0, center 0 0 of the ellipse of the auxiliary circle x square plus y square are assumed as y equal to m1x and y equal to m2x, where m1 m2 are the gradients of these two line segments and m1 m2 are the gradients of these two line segments. Line segment means line segment joining these 2 points with the center, that is center of the auxiliary circle, that is ellipse. Auxiliary circle is a square. These are two line joining with the center. Line joining of the extremities of the tangent, that is the point of intersection of the tangent with the auxiliary circle with the center of the ellipse are this and this. M1 M2 are the gradient of these two line joinings. Now, also x1 y1 is on this line, that is y1 equal to m1 x1 and also x2 y2 or x2 y2 is on the line y equal to m2x, that is y2 equal to m2 x2. Now, these two lines are mutually perpendicular because the point line joining of the point of intersection to the center of the ellipse, that is center of the auxiliary circle, subtend an angle 90 degree, subtend an angle 90 degree. These two line joinings subtend angle 90 degree at the center of the ellipse, that is center of the auxiliary circle. So, these two lines are perpendicular to each other. So, we can write y equal to m1x and y equal to m2x are perpendicular to each other, perpendicular to each other. So, the product of the gradient must be equal to -1. So, product of the gradient of these two lines must be equal to -1, must be -1, m1 m2 equal to -1. So, the product of the gradients of these two mutually perpendicular lines must be -1, that is the product is equal to minus 1, gradient, product of the gradient equal to minus 1. So, m1 equal to y1 over x1 and m2 is y2 over x2 equal to minus 1. So, y1 y2 plus x1 x2 equal to minus equal to 0, y1, and also we have already got the value of x1 x2 and y1 y2. We put these values of x1 x2 and y1 y2. Y1 value of y1 y2 is a square b square minus a square b square cos square theta over a square sin square theta plus b square cos square theta plus x1 x2, value of x1 x2 is also got as a square b square minus a4 sin square theta over a square sin square theta plus b square cos square theta equal to 0. So, this is a square b square minus a square b square cos square theta plus a square b square minus a4 sin square theta equal to 0. So, 2a square b square, 2a square b square minus a square into b square cos square theta plus a square sin square theta equal to 0. So, 2a square b square minus a square into cos square theta is also 1 minus sin square theta. So, b square cos square theta equal to b square minus b square sin square theta plus a square sin square theta equal to 0. So, 2a square b square minus a square b square plus a square b square sin square theta minus a4 sin square theta equal to 0. That is a square b square plus sin square theta minus sin square theta into a4 minus a square b square. So, sin square theta equal to a square b square over a4 minus a square b square, which is b square over a square minus b square, that is 1 over 1 minus b square over a square. So, sin square theta equal to b square over a square minus b square, which is equal to which can be written as 1 plus sin square theta, 1 plus sin square theta equal to 1 plus b square over a square minus b square, which is a square over a square minus b square. So, 1 plus sin square theta equal to if we divide numerator and denominator by a square, we get 1 over 1 minus b square over a square, which is 1 over this is also equal to the square of the eccentricity, that is e square. E square is E is because E is root over of 1 minus E square. This is the eccentricity of the ellipse. This is the eccentricity of the ellipse. So, this equal to 1 over E square. So, we have proved this, that is 1 plus sin square theta equal to a square. 1 plus sin square theta equal to a square. So, we have got this result, that is this result is 1 over E square equal to 1 plus sin square. So, we have proved this.